Welcome to the next wee bit of Unit 2, which is cracking. So we're kind of taking a step back and we're going to National 4 stuff. So this is actually only going to be quite a short video. There's not that much you need to know about it, so let's just get going. So just a wee reminder of fractional distillation, so that'll help you out with the understanding behind the process of cracking and why we're actually interested in it. Okay, so we've got a fractionating tower, which you've all seen before, wee diagram of it just to remind you. So things to think about. So long or short chain molecules, whereabouts are they in the column? So at the top we've got our short chain molecules, and at the bottom we've got our long chain. Thinking about the bottom of the column, so thinking about like the different uses of the different fractions after your oil's been refined. So it's quite important that we understand what fractions are most important for us in society as well. So remember at the bottom we've got the fraction that we call bitumen. Okay, and then kind of in between we've got things like fuel oil, we've got diesel, we've got petrol, we've got naphtha as well, which goes on to make the chemicals, and at the top we've got our bottled gases, so kind of like camping stove gas and stuff like that as well. So at the bottom we've got our long chain molecules, so normally there's round about, well, there's always kind of over about 25 carbons in the molecules of bitumen. Okay, so back whenever we looked at fractional distillation, we spoke about the fact that these kind of compounds down here, they're quite viscous. So remember that just means that they're quite thick, they're kind of tar-like rather than petrol, which would be quite runny. Okay, so we'll just remind ourselves about that. So not viscous at the top. So the reason for that we're going to talk about a bit down the line whenever we're talking about the National 5 alkane stuff again, which we'll come back to later on. But what we're kind of interested in here is the uses and which ones are more useful for us. So yep, definitely bitumen is useful. It tars roads, it roofs houses and all that sort of stuff. However, as you're probably aware, obviously you are kind of too young to drive at this point in time, but you might have heard people kind of talking about how oil, petrol, diesel, the price is always kind of skyrocketing, so it's really, really expensive. Okay, so the reason for that is coming up on the next slide. So basically what we're kind of thinking about here is which products from fractional distillation are the most valuable to us. So probably things like the aircraft fuel, petrol and diesel, they are quite in high demand, right? So let's have a wee look at this graph just to kind of show you where we're going with this. Okay, so what we've got is a bar graph showing us the supply and demand of fuel oil and petrol. Okay, so the orange column being the supply, so this is actually showing us that we've got quite a lot of fuel oil but not as much petrol. Okay, so you can see that column's obviously quite short in comparison, and then the blue column we've got our demand. So fuel oil, the demand is quite low compared to how much we've actually got of it, and the petrol, again, as you're aware, more and more people are getting cars. There's more cars on the road now than there ever has been. Okay, so that's why the demand for petrol has skyrocketed and hence why it's more expensive. Okay, so what's that got to do with us? So what we're kind of looking at is this process of cracking. So basically all it is turning hydrocarbons that we don't really need as much, that are quite long chain, we can actually break them up and convert them into shorter hydrocarbons that we can use and that we do want more of. Okay, so that's the kind of whole point of cracking. So let's have a look. So you might want to pause the video in a second once I just kind of spoke through this. So this is kind of what I've just said anyway. Basically all you need to be aware of at the National 4 level, so for those of you that will be National 4 next year, this is a definition you will need to be aware of. So it's just the process used to meet the demand for shorter alkanes and alkenes. So that word alkenes there we've not really spoke about, but we're going to go on to that in the next video. Basically all it is breaking larger hydrocarbons into smaller ones. Okay, so for example, if we had a big, massive, long chain hydrocarbon, say with 25 carbons in it, what we can do is literally, chemically, break the bonds and we can turn those into shorter hydrocarbons. Okay, so obviously I've not went to the effort of putting all my hydrogens in here for obvious reasons because we'll be here all day, but hopefully you get the gist. So what you need to be able to do is write these wee equations. So it's very, very straightforward. All you need to do is make sure that the number of carbons and hydrogens are the same on both sides. So this example here is kind of showing you what would happen if you broke up this big 28 carbon chain. What we've got on the right hand side is quite a short hydrocarbon here, 8 carbons in it, 16 hydrogens. We've got an 18 one as well, which is still quite long but could probably be used for different things. And we've got this very short molecule here, which is C2H4. So what could be asked of you is that you could be given kind of like half an equation like that, and then you're kind of asked to work out what this compound is, so what the chemical formula would be. So if you want to pause the video, you can, and you can try it for yourself. So the tip is just to make sure that the carbons and hydrogens are the same at both sides. Okay, so I'll give you a wee second to pause that and we'll go through the answer. So what you should have worked out is that we should have 4 carbons in this compound. So 7 plus 14 is 21, so we've got 4 left over to make up the 25 over here. And for your number of hydrogens, you've got 30 and 14, which is 44, so that leaves you with a total of 8 hydrogens left over. Okay, so the other compound we're making is C4H8. Now, we've looked at the alkanes for a couple of weeks now, so hopefully you're feeling pretty confident about that. So a couple of things to think about. General formula of the alkane. So remember that allows you to work out the chemical formula of any alkane. It allows you to identify if things are alkanes as well. So just a wee reminder, the general formula is CnH2n plus 2. So bear in mind, that means that if you've got a certain number of carbons, you just multiply that by 2 and then add 2 on, and that'll give you a number of hydrogens, okay? So what I want you to think about whenever we're looking at these types of cracking equations is what the products actually are, okay? So some of them actually aren't alkanes. So the reason you know that is because with this chemical formula here that we've just worked out, C4H8 doesn't actually follow the pattern of the alkanes, okay? So that is not CnH2n plus 2 because you've got 4 carbons and only 8 hydrogens, which is just double the number of carbons, so it can't possibly be an alkane, okay? So what we're actually doing here is turning these long chain molecules into shorter alkanes, but also into a different set of compounds which we can use for loads of different stuff, which we're going to talk about in the next video, okay? So that brings us on to the alkenes. So you'll notice that the name's very similar to the alkanes, but the ending is slightly different. So it's just another set of compounds, it's another homologous series, so another set of compounds that act very similar, so they've got the same chemical properties and the same general formula, okay? The only difference this time is we've got double bonds in here, okay? So say for example we took an 8 carbon alkane, right? I'll just draw this out so that you can see where this is coming from before we move on to the alkenes. And I'll need to draw my hydrogens in this time so that you can see where we're getting this from. Okay, so say we broke this down the middle. Okay, so what we're going to have a look at now is what is actually made as a result of that. So this is just to kind of show you how the double bond is actually formed, okay? So what we're actually making here is, if we split that up, let's have a wee look. So you don't need to worry about the kind of ins and outs of this for just now, but it's just to hopefully help you with the understanding of where that comes from. So we're going to end up with 2 4-carbon molecules. So we've got our alkane, so we've got our wee butane that we've made. And over this side, this is where it gets a wee bit trickier. Okay, so what we've actually got is we don't have enough hydrogens to make 2 alkanes. Okay, so what we've got in place of that is our alkene. So the difference is that this one has got a double bond between these 2 carbons. So remember the rule that carbons always need to have 4 bonds coming out of it no matter what. Okay, so that's the rule to remember. So I'll stop it there just now and we'll have a wee look at the alkenes in the next video. Okay,